All right, so chord segments. When two chords intersect in the interior of a circle, each chord is divided into two segments. Okay, so this theorem right here says if two chords intersect in a circle, then its products of the lengths of the chord segments are equal to each other. So what it says is AB times BC will equal DB times BE. Okay, so example 1, find ML and JK. All right, so utilizing that formula, these are two chords, they intersect, so we have to multiply it. Okay, so M to N times N to L, so it's X plus 2 times X plus 1 equals our other way, K to N and N to J, X times X plus 4. Now, we're going to multiply this out. Okay, over here, you have to FOIL this. Multiply it. Okay, x times x is x squared. X times 1 is x. 2 times x is 2x. 2 times 1 is 2. On this side, distribute. It's only one term, so you're only going to distribute. X times x is x squared. X times 4 is 4x. Okay, now I'm going to just simplify things. I can combine these terms on this side. So I have x squared plus 3x plus 2 equals x squared plus 4x. All right, now I'm going to start moving things around to figure out what x is. X squared, if I subtract it over, they kind of just go away. Okay, so I'm going to just get rid of it. I'm going to move my 3x to that side, so minus 3x to both sides. 2 equals 4x minus 3x equals x. Okay, so I found x. That's not what the question asked for, but that's a very big start. Okay, finding x. I now need to find ML. I'm going to write that down so I remember. M to L. Okay, I have to plug it in. So it's 2 plus 2 is 4. Down here, it's 2 plus 1 is 3. So 4 plus 3 is 7. M to L is 7. The next one I have to find is J to K. J to K. J to K. Here we go. All right, so X, that's just 2. Plus 2 plus 4 is 6. 2 plus 6 is 8. J to K is 8. All right, you guys are going to do example 1A. It's a tad easier. There's just not as many variables in that problem for you guys to look at and complete. All right, I'm going to look at example 2 with you guys. All right, external segments is the part of the segment, or a part of the secant segment that is outside of our circle. All right, so there's a formula for this as well. It says if two secants intersect in the exterior of a circle, then the product of the measure of one secant segment and its external segment is equal to the product of the measure of the other secant and its external segment. All right, so what this basically says is A to C times AB. So it's the whole line times the exterior is equal to the whole line times the exterior. All right, so we're going to look at this together for a second. I'm going to do example 2. I'm going to do 1 with you, and I'm going to do 3 with you. Okay, you guys are going to do example 2 because it's the same concept we just learned on the first page of the notes. All right, so it's the whole line times the exterior. So the whole line is 6 and 9, which is 15 times the exterior of 6 is equal to the whole line is x plus 5 times the exterior of 5. All right, now we're just going to simplify. 15 times 6 is 90. Distribute this, we get 5x plus 25. Subtract your 25 over, you get 65 equals 5x. Solve, you get x will equal 13. All right, pretty easy one. When you guys do 3a and 3b, I would like you guys to make sure you look at this problem to follow the steps that I just did. Okay, we're going to do this one as well. This one is a tad longer of a problem, so make sure you kind of write a little small and leave some space. All right, so this is, remember the formula. It's the whole line times the exterior. All right, whole line is x plus a 3 and a 2 makes 5 times the exterior of 3. This one is the whole line. I have an x and an x, so that makes 2x. I have a plus 1 and a minus 1, goes away, times the exterior, which is x plus 1. Now, I'm going to distribute here. 3x plus 15 equals 2x squared plus 2x. All right, so now there is going to be no canceling this 2x squared out. All right, so I got to move everything over and I'm going to have to factor this. Okay, so subtract 3x, so I have a 2x squared, nothing combines with that. I subtract, I get a minus x. I subtract that over, I have a negative 15 equals 0. Factoring this, negative 30 goes on top, and a negative 1 on bottom. This problem should look familiar if you looked at my review on factoring and the quadratic formula. Okay, this is an example that's actually in those notes. So, our numbers are 5 and a negative 6. When we factor this, you get 2x plus 5 and an x minus 3. All right, they equal 0. Remember, zero product property set both of them equal to 0. You get 2x plus 5 equals 0, which you'll get x equals negative 5 over 2. Can you have a negative length? No, you can't. That goes in the garbage. Not even needed. So x minus 3 equals 0. You get x to equal 3. Can I have it's going to be a positive length. So my answer is x will equal 3 and only 3. Okay, most of the time when you're going to do these problems, one of the answers is definitely always going to get crossed out when you have to factor. One of them is going to be negative. You can't have a negative length. It goes away. All right, you guys are going to try 3a and 3b. All right. Our last formula for the day. It says, if a tangent and a secant intersect in the exterior of the circle, then the square of the measure of the tangent is equal to the product of the measure of its secant and its external segment. All right, so what it says is, since this is the tangent, so it's jk squared is equal to the exterior times the whole line. So the same formula we just did on the last set of notes. All right, so use the figure to find RS. They want us to find the length of RS. So I'm going to look at the tangent first. It's the tangent squared, so it's 16 squared equals the exterior times the whole line. So it's x times x plus 8. All right, I'm going to just do the math. 16 squared is 256 equals, distribute, x squared plus 8x. I'm going to move my 256 over, so I have x squared plus 8x minus 256 equals 0. I'm going to tell you right off the top of my head, I don't really know that many numbers that multiply to 256. You can sit here and try to figure out the factors that multiply to 256 that add to 8. But I'm going to use quadratic formula just because it's simpler, easier, faster, because I don't know the factors of 256. So negative 8 plus or minus square root b squared, so that's 64, minus 4 times a times c, which is negative 256, all over 2 times a. All right, I'm going to do the math here. You can do most of it in your calculator. Negative 8 plus or minus 64 minus 4 times 1 times negative 256. I did all of that work right there, and that's going to be 1088 over 2. Now, I can tell you that me deciding to use the quadratic formula was a good idea because it's not going to come out to whole numbers here. Okay, it is decimals. So I'm going to get my two different answers. Negative 8 plus radical 1088, it equals divide by 2. And I'm going to do the same thing. Negative 8 minus the square root 1088, it equals divided by 2. Negative 20.49. All right, well, this is negative. Can't have a negative distance. It's out. This is what x is. I solved. That is the length of r to s. Okay, I would like you guys to do example 4, which is the same concept, finding r to s, and I would like you to do example 5. They're a little bit more practice problems for us to make sure we understand how to complete these problems. Some are easy, some are a tad harder. Please reach out to me if you need any help with any of these concepts. Hope you guys have a great day.